Right, so what we're going to do here is we're going to do the integration for this particular one. So the secret with these questions compared to what you've done elsewhere is that we don't have this in the form of ax plus b inside the bracket. So that's the true indication of you can't do it using the rules that we've given you, alright? So if you don't have the rules, then you have to use the substitution method. And generally the substitution is always going to be something which is inside the bracket or to the power of something. Now, I'm thinking that's x cubed, that's going to be x squared. So when I differentiate that inside, I'm going to get that term there. Alright, so that's what I can see in terms of the process. So what we're going to say is let u be equal to x cubed plus 1. So when I do my du dx, I differentiate that, what am I going to get? I'm going to get 3x squared. That's easy, isn't it? So I'm looking for my differentiation to be this thing over here, because the application we've got here really is, this is my f of x, okay? So this is my f of x function. Actually, no, I'll do it in the terms that we've got. Alright, so what we're looking at here, I'll get rid of this bit here. We're going to call this u because we're now saying this is a function of u. Now if we have our du dx, and then we times that by dx, then that now leaves me with fu differentiated with respect to du. Alright, so you just got to be careful how you say that, I suppose, don't you? Alright, in terms of this thing over here, that's what I'm looking for, okay? I can recognise this term here as being this bit here, can I? So therefore I can actually write that as du dx. So let's now do that in terms of what we've got. So this is equal to the integral. Now I'm going to say this whole thing here is u to the power of 4. I'm going to say this thing here is in fact du dx, and we're differentiating that, integrating that with respect to x. So that cancels out and leaves me with u to the 4 with respect to du. Right? So if I now do that integration, that's going to be u to the power of 5 all over 5 plus c, which is equal to simply x cubed plus 1 to the power of 5 all over 5 plus c. Now remember, c can be anything. It could be a value like 10 or 20 or 30. It's a constant value. We don't know what it is because we know when we differentiate, when we integrate that or differentiate that, it's actually going to disappear. Does that make sense? Now I could check that it's true by actually doing the differentiation, couldn't I? Okay, that would become 5 over 5 to the power of 4, and then I have to do inside the bracket it becomes 3x squared. Alright, so it's the opposite of differentiation is what our integration is, what we're doing here. Let's do the second example. Second example is we've got this particular thing. Now, what is the bit that I'm going to make my u? That's the question you're going to ask yourself. And if it's one of these examples, it's generally always the power bit. Okay, it's always the power bit with my exponentials. And you should be recognise the highest power term is x cubed. So therefore, when I differentiate, it's going to get x squared. Alright, so that's what I'm going to choose. So let's say let u be equal to x cubed plus 1. Now I differentiate that, du dx. That's going to give me a value of 3x squared. And so therefore I can identify this term here as being pretty well the same as that term there, but it's missing something, isn't it? It's missing a 3. Alright, so I can get a 3 in there by simply putting it in there, but then I have to put a third out the front, don't I? Alright, so I can do that as long as I'm consistent with what I'm doing over here. I've got to do that third. So I'm going to write this now as equal to simply a third the integral of e to the u du dx times by dx. Okay, get rid of that. And so now we can just say, well, it's going to be a third. What's e to the u? E to the u, isn't it? Plus c. So we can just write that as simply a third e to the u, which is x cubed plus 1 plus c. Alright, so that's it. In terms of that example that I've got there. So whatever term I've got there, I'm always looking to find the differentiation in the other term. That's what I'm looking to do. Do you want me to do one more? Yeah. Alright. So we're going to do one more. Let's just pick another one. Pick one from the thing over here. Do you want to do one of these? Pick one for me, please, Joel. Pick one for number 3. 3F. 3E. Can you read it out? Because I'm going to do that. I'm going to find it. So 3E is going to be what? 4x take 10
over 5x
take x squared dx. Alright, so which one am I going to pick to be my u? Going to pick my bottom one, aren't I? Alright, so that's what I'm looking for. Now, because that is to the power of 1, isn't it? What do you think is going to happen with that? That's really, can you recognise that as being like the ln? Can you recognise that being the ln? So if I pick that over here, let's just do it anyway, like just go play and just get into it. So if I've got f of x is equal to, oh sorry, not f of x, what do I have to say? I'm calling it u. Alright, so let u be equal to take x squared. I'm never going to live that down, am I? It's a bit like they're saying surds are not turds. Surds are good. Alright, make life easy for us. Alright, du dx is equal to 5 take 2x. Now, what you have to do is recognise that there as pretty well being that term there, isn't it? Can you see that? So if I times, you can do it down this way here, you can just find a technique that works for you. What would I need to times this by in order to get that term up there? Well, I have to times it by -2, wouldn't I? Is that right?
Yeah, -2,
so if I times that by -2, both sides there, that's going to give me 4x take 10. Alright? So 4x take 10 is going to be like -2 lots of du dx. Alright? So I can now write this, if I write it down, that's equal to the integral of 1 over u times by -2 du dx. So get rid of that. Now I can bring the 2 out the front because that's just a constant value. Right, so -2 1 over u du, isn't it? So what would that become equal to? Well, that's equal to -2 ln of u plus c. So that's going to be equal to -2 ln of, now what was that value that we said? That's going to be 5 take x squared, 5x take x squared plus c. Now we've got to have our modulus values there because that has to be positive. Alright, so there's 3 very simple examples of doing that. Now for me, these are really easy to identify because you don't have them in the form of ax plus b. Alright, so it's pretty obvious that you need to use this technique, and you are always looking for, once you pick your u value, the thing with the highest power there, you're always looking to make sure that du dx is in here somewhere. So you have to change it around by timesing by some constant values. Right? Always going to be constant values you're timesing by. Right? You can do what you like as long as you do it, timesing by half, dividing by 2. So the opposites, you know, doing that. So if I times by 3, I have to times by a third as well, right, to bring that out there. Hope that helps. Let's see.